Good. Let's get started. So thanks for joining in this webinar offered by Amazic and Vision. We're very glad to have you here. It's a very short webinar. It's only going to take 30 minutes of your time, but I think are going to be very valuable 30 minutes for you to get to know a little bit more GitLab, Kubernetes, and how you can use these tools to your advantage when you're using DevOps methodologies. So first of all, very quick introduction. My name is Adrian Kosmaczewski. I will be the host tonight for you. I work for a company called, if I turn on the remote control, it's much better, right? I work for a company called Vision. So this is how you pronounce the name. It's named Vision. We are 45 people. It's been founded in 2014. And we are the leading DevOps Kubernetes partner with 24/7 support. And of course, we are also very fond of GitLab, and we help customers with their GitLab installations. We are certified ISO 27001. We've been we have report 1 ISA 3402. That means that we work with financial institutions here in Zurich. There's a few of them, as you can imagine. And we have been, back in 2016, the first Swiss company to get certified Kubernetes. So we really breathe all of these technologies that you see on the screen. Moreover, GitLab, we are very fond of GitLab. We are thrilled to be GitLab partners. There's a lot of things we do with GitLab. We help customers with their GitLab CI/CD setups. That's one of the things we do as well. And we've got two big products as well. Apuyo, it's the Swiss container platform. It's based on OpenShift, and you can run your containers securely in-house in Switzerland. And Project Sin is a multi-cloud cluster, multi-cluster support tool. So it allows you to manage lots of different Kubernetes clusters from one console. And this is something we use every day. But enough of the marketing speak. Let's go to the agenda for today. And the agenda for today, first of all, we're going to talk about DevOps a little bit, just a bit quick recap about why DevOps is important, how your team could be using DevOps to your advantage, how could you change the culture in your company using DevOps principles. Then we'll see how GitLab helps you in this respect, how GitLab makes your DevOps initiatives better and faster. We're going to see how GitLab and Kubernetes play together. We're going to see it's very simple, but it's really cool. And we're going to have a demo. It's a live demo, actually. So I hope the demo gods are with me tonight. We're going to actually be integrating a GitLab project with a Kubernetes cluster, and we're going to see the deployments in real time. And of course, there's going to be time for a couple of questions, so don't hesitate to write them down. I think the attendees have the possibility of writing down questions. And Marcus and Milo from Amazic, Marcus works with me in Vision, of course. They are both going to write them down, and we'll see at the end to get some answers for you. Very good. The world of software development has changed dramatically in the past 40-50 years. So we've gone through several technology waves, but the most interesting part of this table that I borrowed from Adrian Kosmaczewski, who is lead dev architect at AWS. So he really knows what he's talking about. And he really perceived that the risk of new deployments, the risk of new projects is going down dramatically. The cost of these new projects is going down dramatically. Previously, a failure could cost you a bankruptcy of your company. Right now, a failure on deployment is basically just a few seconds or a few minutes of downtime. You can recover very quickly. So we've gone through a shift in the way software is delivered. And we like DevOps a lot. If you look at the bottom of the screen, it really says Vision, the DevOps company. That's what we do. We breathe DevOps to the limit, and we embrace the 3 ways of DevOps. What is this thing, you might ask? Whenever you apply DevOps principles to your team, the first thing you have to do is apply the principle of flow. And the principle of flow means that you reduce the batch size of whatever it is that you do. You make it smaller, and you increase the frequency of what you do. You basically create a flow of work from development to operations to the customer. This is something that begins little by little to take shape. But the important thing in mind, it's always to reduce the batch sizes. This is very important. Whatever it is that you do, whatever change you want to bring to your software, make it small. it's easier to review, it's easier to develop, it's easier to test. This is the first thing. And increase the intervals of work. Make these intervals of work, decrease the intervals of work. That means make these changes more often as time goes by. This is the principle of flow, and it's the first way of DevOps. The second way of DevOps is the principle of feedback. It is extremely important in order to reduce the impact of mistakes, to have continuous feedback, not only from humans, which is very important, and we're going to see how GitLab can help you with that. But the second most important thing is to have feedback from the systems themselves. Logging, testing results, all of that has to be fed down to the development team. They have to be able to act on that data as fast as possible. This is very important. It's the second way of the DevOps principle. The third one is the principle of continual learning and experimentation. And for this, and this is the most difficult one, paradoxically, you need a high trust culture. You need to have a culture into which it is okay to fail. You try new things. And guess what? GitLab actually can help you do that as well. So these are the three ways of DevOps. And I haven't invented this, of course. There's very good books that talk about it. The first one actually dates from the 1980s, and it's called The Goal. It's a book by Eliyahu Goldratt, and this is a classic in management, not software management, but in general management. And somehow the Phoenix Project, which is the novel that has somehow brought DevOps to the light in the mid-2010s, it's a rewriting, and very, very openly so. The author acknowledges the tremendous influence of The Goal in the writing of the Phoenix Project. We've got then the DevOps Handbook, an incredibly, very simple, very straight to the point book. You gotta have a copy of it. It's totally worth a read. And the second part of the Phoenix Project just came out last year, and it's the Unicorn Project. And all of these are on my library. This is actually a picture I took this morning preparing the slides. Very good. Enough for DevOps. Let's talk about GitLab and DevOps. How can DevOps work with GitLab? How can GitLab help you in your DevOps initiative? Today we're going to see three things that are key for you to apply the principles of flow, feedback, and continuous learning into your organization. The first one is, of course, the CI/CD pipeline. Anyone who has used Jenkins or any CI/CD tool knows the tremendous benefit that this brings to your system. Imagine this being baked into your software repository, your Git repository. This is exactly what GitLab brings, and with great power. And of course, CI/CD pipelines help in the flow, the principle of flow, and the principle of feedback, of course, because you can get immediate feedback about what's going on with your software. Are the tests passing? Is the software building or not? Did someone break the build, and so on. The second element that GitLab helps a lot for DevOps is merge requests. Of course, because of the feedback, because you can have a discussion around the change with your peers. You can have code reviews directly on the same tool where you're storing your source code. This is tremendous. This has tremendous value for teams of all sizes, and I strongly recommend that you get into the habit of creating merge requests and sharing them with your team. Actually, we're going to create a small merge request this afternoon in this demo, so stay tuned. The third thing that brings a lot of value from GitLab to the third principle of DevOps, which is continuous learning and experimentation, is the integrated container registry. Because containers are a great thing. Lightweight, easy to build, and we can have several versions of them. And the great thing is that GitLab provides an integrated container registry, ready to use, accessible from the outside world, and it provides a lot of value for your teams to be experimenting with different releases, different versions of different features at the same time. This has tremendous value. And all of these three features in their own way support the DevOps principles of flow, feedback, and continuous learning and experimentation. Let's talk about GitLab CI/CD first. How do you enable CI/CD in GitLab? Very simple. You gotta create a small file called gitlab-ci.yml. So of course, the format is the YML format. It's very human readable. It's quite easy to create. And GitLab provides templates, so you don't have to start from scratch. Actually, creating a new GitLab.ci, GitLab-ci.yaml file on your project is actually very simple. You just click on a button that says set up CI/CD on top of your project, and you're shown the form that is appearing on the screen right now that allows you to select different templates. So depending on whatever you do, whatever technology you're using, you're going to find something for your needs. In our case, in the case of this particular example, I selected the Docker template. Why is that? Well, because we're going to talk about Kubernetes, and Kubernetes is, after all, a container platform. So we are going to use what I think is the most generic and most useful of all of the GitLab CI YML templates, which is the Docker one. And this is what it looks like. Literally, we have here a couple of variables. You can select variables, and then you can reuse those variables later on. Like right here, for example, I'm reusing those variables. And of course, you can reuse different chunks of definition. Here, for example, I'm defining a base definition task, if you want, and I'm extending it right here. GitLab CI/CD pipelines are based on the concept of stages. So in this case, I'm just using the very basic build and deploy stage. You could have as many stages as you need. You can have a test stage. You can have a deployment to an integration server. You can have a deployment to a temporary server, so on and so forth. It's up to you. It's very, very flexible. You then reference the stage that each step in your GitLab CI/CD refers to. In this case, build. And here I have tasks that are executed in some branches only. And this is very interesting. Here I have a task called Docker build master. It's only executed on the master branch, while this one, Docker build, it's executed in all the branches except in master. And whenever I execute this task right here, I first execute the base task right here. So that means that I log into my registry. And then I build my project and I push the result to the local registry. All of these variables that you see right here, CI registry image, CI registry password, and so on, are automatically set for you by GitLab. And this is very useful because that means that we can use off the box not only the Docker building facilities of GitLab, we can actually store the product of our builds directly there. So this is really cool. And we have here a deploy deploy step that basically belongs to the deploy stage that uses kubectl. Kubectl is the tool that the command line tool that you use to talk to the Kubernetes API, and that allows you to do what? Of course, to apply a deployment and then to restart that deployment. So that means that every time that we commit something on the master branch, every time we push a change on the master branch of our GitLab repository, we are going to automatically redeploy our application. And this is quite powerful. We're going to see it. We're going to see this in action. Speaking about Kubernetes, I've already mentioned a little bit. The important thing to know is that GitLab and Kubernetes are completely compatible with all Kubernetes distribution. Here at Vision, we are actually using in production GitLab and OpenShift, GitLab and Rancher, GitLab and managed Kubernetes in EKS, AKS, Google Cloud, doesn't matter. It all works thanks to the standardization of the Kubernetes platform, which makes it so powerful. And it also works, and this is very interesting, with any kind of Kubernetes flavor, including the ones that run on your laptop, the ones that are used for IoT scenarios, like, for example, Minishift or K3D or MicroK8s. There's quite a few of them as well available. This opens the door to a lot of very interesting possibilities, whereas you can actually deploy code live on IoT scenarios all over the planet in distributed networks. And this creates very interesting possibilities as well. In our demo, we're going to use Minishift, not MicroK8s. We're going to use Minishift, and Minishift, what I'm saying, Minishift. No, it's Minikube. I'm sorry. That's a typo on the slides. It's Minikube that we are going to use, which is another standard Kubernetes distribution. How do you integrate GitLab to Kubernetes? Well, there's a form you have to fill, like literally. You have to fill the form, you give it a name, you specify the URL, you provide a security token, and it's done. Literally, there's nothing else to do. The GitLab image registry is fantastic, and given the current changes in Docker Hub, it becomes a very, very interesting option for storing your own images there. You can use it directly in GitLab CI.yaml. It's completely and automatically configured. You get one registry per project, but you can store as many images with different tags as you want, so that's very convenient. And of course, it can be accessed from the outer world. We can access it from your command line if you want. You can pull and push images to it, just like you would with Docker Hub. If we have time, I'm going to demo that as well in a few minutes. Very good. How does it look like? This is how it looks like. Literally, there's a tab on your GitLab project where you can access the GitLab registry. And when you have several tags for your image, this is how they look like. But enough talking, because you want action, I know, and I actually prefer action as well. So this is the demo that I'm going to show to you today. I have a project that I will create live in front of you on gitlab.com. That project, I will configure it to talk to a Kubernetes installation, which is actually a Minikube installation. I wrote on it right there. And this Minikube is exposed to the outer world through ngrok. ngrok is a reverse proxy. It allows me to expose some localhost services only to the outer world. So I'm basically, this way I can have these both systems talking to one another, and very interestingly, I can inspect the traffic coming from GitLab to my server and the responses as well. So it's very nice. I can see how the Kubernetes API works in real time. Okay, so let's do that. So I'm gonna stop sharing for a second, and I'm going to change a little bit the configuration of my screen. Very good. This, I will send it to that. And here we are. Very good. Good. Let's share the desktop. And here we are. So I hope you can see the screen. I hope you can see, given the size of the font, I made it as big as possible. On top of the screen, I'm running tmux on my terminal, so I'm able to multiplex several different terminal sessions on the same screen. On the top, I have Minikube. You can see the command Minikube start with 4 gigs of memory, 60 gigs of disk size, and 4 CPUs. That's running right now, and I'm exposing via kubectl. I'm kubectl. I'm exposing the API on port 8001, and then I use ngrok to expose localhost 8001 from this very URL that I'm going to copy right now. There we go. So now I go to GitLab. This is gitlab.com. I am logged in as my own, so this is my own personal account. It's always Akosma, so if you want to follow me in Twitter or anything, it's very simple. You always go to Akosma. And I will create this project, and this project is public, actually. So you can actually go and see it. You should only take care of this, gitlab.com/akosma/webinar GitLab and Kubernetes. This is an open source project. It's open in the wild. You're going to go check it out. And as you can see, it's completely new. I have nothing here. So the first thing I have to do is to go to the operations tab and configure a Kubernetes cluster. And in the operations Kubernetes, you can integrate a new cluster with a certificate. I will click here with this green button, and I will select the option to connect an existing cluster because I already have a cluster running. And I will call it Minikube. I will paste the API, and I will now select the option GitLab Managed Cluster. Now, of course, I need some kind of security enabled to be able to talk to this cluster. I need a service token, and the service token is scoped to kubesystem with the cluster admin privileges. How does create that? Well, that implies a little bit of YAML. So let's go to I have a project, which is the project that I will end up pushing to GitLab. And if I go to my project, I see first What is it? It's basically a Flask Python application. It's a very simple API. Whenever you call the route, the root route in my API, you are able to see some text that it's basically coming from the fortune command. I don't know if you know the fortune command on Unix and Linux in general. It gives you a fortune cookie. And the fortune cookie is one of these messages you can read when you break the cookie, and you have a fortune message that tells you the future somehow. So this is exactly what this services does, and basically it responds to JSON if you want. It also responds plain text, or it can respond HTML by default. This is a very simple thing. What else do we have here? I have a Docker file, of course, because I want to containerize this application. So I'm using the Python 3.7 Alpine. I'm adding the fortune tool. I then use PIP, the standard Python package installation tool, to install all of the packages, all of the dependencies of my app. I copy the files of my application. I drop the root privileges. I don't want to run as root. This way I can reuse this container image, for example, in OpenShift, that doesn't allow containers running as root. And then basically I expose port 9090, and I can talk to my image, to my container, excuse me. We have a template. It's a very simple template used by the application. Whenever you want an HTML response, you've got all the text in green, and you can see the text of your fortune cookie appearing on the screen. Very simple. There's more stuff that are very interesting here, which is the deployment. This is a standard Kubernetes deployment. And of course, I'm specifying that the image of this deployment comes directly from the GitLab registry itself. So this is an interesting point. We will have the GitLab talking to my Minikube to deploy the app, but in order to deploy properly, my Kubernetes has to be able to access my GitLab repository to get the images. Good. So back to what I was saying previously regarding this service token. Where do I get the service token? Well, I need a service account called GitLab in the namespace kube system, and I needed to have the cluster role cluster admin. That is exactly the cluster admin privileges they are talking about right here. And of course, if you click that link, that's how I learned, because you can go and check the documentation. That's really cool. Let us kubectl apply service account YAML. So now I've created in my Kubernetes cluster, I've created this service account in such a way that I can reuse it. And now what I need to do is to get the name of the secret that has just been created. And this secret comes directly from the kubectl kubesystem get secret command. I grep for the name GitLab, and I get only the name. That's the only thing I'm interested right here. So I store that in a variable called GitLab secret name. So now I can do kubectl, and I can, in the kubesystem namespace, get the secret GitLab secret name. I only want the element called data token. I encode it as I decode it in base64, excuse me, and then I save it on my clipboard. So I just hit enter, and then when I go back to my user interface, I can paste my service token. And now I can add the Kubernetes cluster, and I will ask you to pay attention to this tab, because here I am inspecting the traffic through ngrok that's coming from GitLab to my machine. So I will click add Kubernetes cluster, and look at what happens. All of a sudden, somebody's talking to my Kubernetes cluster, and it turns out that the requests are coming from 7490. And if I go to the documentation of GitLab, they tell me that gitlab.com is using the IP range 7490. So this whole range is solely allocated to GitLab. So this is actually GitLab talking to my Kubernetes cluster and making sure that everything works. So that's great. We have GitLab talking to our Minikube. Now what I need is being able to talk from my Minikube to GitLab in order to pull images. And for that, I go back to my project, and I will go to Settings Repository. In Settings Repository, I can create deploy tokens. A deploy token is what I'm going to use to connect from my cluster to GitLab to pull images. So this deploy token, I'm going to call it Minikube. And you could specify an expiration date. We're not going to do that. And here, I'm going to use the standard format that they suggest, GitLab deploy token 01, and I need to apply the scope read registry. Of course, I need to be able to read images so I can pull them. This is exactly what I need. I don't need any other scope right here. So I click OK, and here I have my username for my token. So I go back to my user, my terminal line. I can set a couple of variables. GitLab user. And as you can see, I've done this before. I'm going to copy the token value. This is the token, VYXS, yeah, that's good, very good. And now I can create, I'm going to move this window, there we go, much better. I have to create this kind of structure. I'm basically baking a base 64 of the GitLab user and token that I've provided, that I've got previously, and I'm going to create this JSON token. And this JSON token now, I need to do something else. I need to base 64 it, and I copy it. Very good. And then I need to create a Kubernetes object that will carry that token to my Minikube. And here I have exactly what I need. There we go. This is a secret that I'm going to store inside of my Kubernetes, of my Minikube, that will give the Kubernetes the possibility of pulling images out of GitLab. And this is really great. So now I can just kubectl GitLab Kubernetes demo. No, of course not. This is not going to work. And the namespace is webinar GitLab and Kubernetes. Apply config / what was the name again? I forgot it. There we go. kubectl webinar GitLab and Kubernetes apply /f secrets / GitLab pull secret YAML. Very good. The namespace does not exist. Of course, I haven't created it. kubectl create namespace webinar GitLab and Kubernetes, and now I can apply this on the proper namespace. And here I'm using a small tool called K9s. If you're not using K9s for your own Kubernetes needs, you should. It's really awesome. And here you can see this namespace I just created, webinar GitLab and Kubernetes. And here I can see secrets. I can see my GitLab pull secret that I just created. So this is awesome. This is very simple. I'm going to change now to the deployments screen so I can see my deployments. As you can see in this namespace, I don't have any deployment so far. Very good. No problem about that. We are going to now git push. No, I cannot because I haven't set any remote here. So git remote add origin. I will add the default origin that you get on GitLab when you create a new project. It tells you git remote add origin, etc., etc. So there we go. And now I can git push. Of course, I should set up stream. There we go. Origin all. Very good. So now I go back to my project. I've pushed. Of course, I see a lot of code. I see everything going on. But the most important thing that I see, because I have a GitLab CI CD file on my deployment, and because I committed to master, I'm going to see the stages of my CI CD pipeline starting up. And this is really cool. I can actually click here. I can see little by little. This is going to take around 2 minutes. At least that was what it took when I was doing the demo, when I was trying it. So in any case, what is going to happen here, I'm going to execute all the build of my Docker image, and I will push it to my local container registry, which is right here in packages and registries. I can see the container registry. It's starting to start. Well, as you can see, I don't have good luck right here. It should have started and be a bit faster than this. Sometimes it takes a bit longer. In the meantime, what I'm going to do is, in my project, I'm going to do a change, and I'm going to ask my team to collaborate with me. So first of all, I have to check out a new branch called Blue. And here in this new branch called Blue, I'm going to create a change. The first change that I want to create is to increase the version of my project to version 1.1. And I want to change the color of my screens from green to blue. Just a quick glance to see if this is starting to run. No, clearly not. Something is going on and I don't know what is. Let's start again. I can go to CI/CD. I can run the pipeline for master. And let's see if this works now. This is very upsetting because it worked pretty well, but this is how it goes sometimes. Anyway, let us continue working on our change right here. So I change my project and I can see the changes that I'm going to commit. I'm going to commit them right here. Commit all m new version in blue. And I'm going to push this to a new branch upstream. And GitLab is kind enough to actually show me the link to create a new merge request. So I'm going to click on that link, and I have this new merge request template. I can specify and explain my team what I want to do. This is better in blue, and I can assign it to me. And I can as well squash commits when the merge request is accepted, submit merge request. There we go. So here I can see all the changes. This is great because people can actually comment. For example, I can have a coworker who doesn't like blue and it says, why not pink? And in this case, I will start a review right here. I can submit my review and basically my coworkers can see exactly what is it that I think about the changes that they want to perform. I'm going to take a quick look once again to my pipelines, and I see that they are not starting, and I really don't know exactly why. Unfortunately, I cannot show you. It should be green, and that should be exactly the way it should be. For some reason, this is not appearing right now. The important thing to realize, and the thing that I wanted to point out, is that you can see here the build stage and the deploy stage because we are committing to master, and here because we are committing to a separate branch, we only see the build stage. So this is great. You can have different behaviors depending on the branches that you're using for your work. So unfortunately, this is not going to work, and we are reaching the end of the webinar in any case. I'm going to leave this for later. I can show you in a different setting. I will probably record a video where this actually works. I'm very sad that the workers, the runners didn't pick up these. I don't know exactly why. And I'm going to go back to my slides and recap what we saw today. So GitLab supports the 3 DevOps principles: the principle of flow, the principle of feedback, and the principles of continuous learning and experimentation. To connect to a Kubernetes cluster, and you've seen it working live, you just require a URL and a token. And the CI/CD pipelines can be configured through GitLab CI YML. You don't need to know everything that goes into a pipeline YML file. You just can use the default templates provided by GitLab. So that's very convenient. And then you can access your registry from the outside world using deploy or personal access tokens. And this is something that probably works. No, yes, it doesn't work because it hasn't finished the build, so I can show you. I should be able to podman pull I hope you're using Podman, not Docker anymore, because Docker is going the way of the dodo somehow. Podman pull, and you can pull the images from your repository. Very good. Before we end, I wanted to point out that we are creating the first GitLab meetup group for Switzerland, and we already have a first event on Thursday, January 21st, 2021. So please sign up. It's completely free. We're going to have great speakers talking about things you can do with GitLab, and with a bit of luck, I will show up and try to make this demo work, which didn't work this time, but that's how sometimes things don't work exactly the way you pretend they will. And we are open for topic ideas. Of course, if you have anything cool that you've done with GitLab you would like to showcase, please get in touch with us. We will be very happy to get you in. So thank you so much for watching. And of course, if you have any questions, I will be very glad to reply to them right now. I will stop sharing, and here we are. So we have Q&A. I can see Q&A. Is there a way to avoid tagging the image as latest? Yes, and I can show you from the YAML yes, of course. Let me show this. I'm going to reshare my screen. There we go, here in the terminal, this is enough. So here, if I show you the GitLab CI YML, for the Docker build that happens everywhere except in master, you can see that we are using a tag that is exactly the same tag as the commit reference slug, exactly the 6 characters of your commit. So this is automatically going to create an image that has a specific commit, and this allows you to basically create different images from different commits at different stages and different points in time. So this can provide some help regarding that, but it's definitely possible. Of course, in the case of this push right here, you're going to have latest. That's what you get. That's the way this is done at this point. I hope this answers your question. I will stop the sharing. So yeah, I see in the chat, we have one question. Mohammed asks if there's a way to avoid tagging the image as latest from the YAML deployment file. I hope I've answered the question in question. Very good. Thank you so much. I don't know if somebody else has a question. Please go on. Feel free to. So no more questions. What are the difference between Podman and Docker? So the biggest difference, this is a very hot topic right now because Kubernetes just announced yesterday that it's dropping support for Docker completely. So Docker and Podman have radically different approaches. One of the major architectural differences between Docker and Podman is the fact that Docker uses a daemon running on your machine, taking care of pulling, pushing, building, and so on. Podman is much simpler in that sense. You do not need to run a daemon. It makes it much more flexible. It's also a fresh version a fresh implementation of the standard of containers, of the Open Container Standard Initiative. So that means that a lot of new features will be added to it. It's a much younger project, very promising. And very importantly, for you in the command line, you can actually do something like this, and it actually works pretty well. Alias Docker equal Podman. And Podman is 100% compatible with all the parameters and all the command line options of the Docker CLI. So all of the things that you know that work in Docker, you can actually start using them with Podman. And seriously, I've been using this alias, and this is why it appeared in autocomplete on my terminal. I've been using this alias for a long, long time without any problem. And this is very interesting as well. You can deploy Podman generated images to any OCI compliant container platform like Kubernetes, for example. So seriously, migrate to Podman is totally worth the change. And yes, I think it's a good option. So great explanation. Thank you so much. Regarding IoT, is cross-platform image already included? ARM64. Good question. I actually don't know. It's something that I should probably check in the documentation. It's an excellent question indeed, particularly for the IoT example that I mentioned earlier. So it's totally a very valid question. I will check it out and try to find the answer. Right now, I cannot tell. There we go. Let's mark these questions as done. I don't know if there's more questions. Please feel, okay, doesn't the kubelet rely very heavily on Docker health checks? Does Podman serve the same properties? So Kubernetes 1.20 is going to drop Docker support. So I assume that all of the things that you could do with Docker previously will be done through Podman or any other OCI compatible container runtime. I seriously don't know at that level of detail if this is exactly how it's going to happen, but I know that Kubernetes 1.20 will drop the support to Docker. So I suppose that these health checks will happen through Podman or some other similar tool. Yes. Any other questions? As each repo has its own registry, how to manage the access between different registries without being a huge mess? Excellent question. This is, again, all explained in the documentation. There's a whole documentation about how to access and how this cross things. I can totally see how this can become a problem, particularly if you have a microservices architecture where you have all of your different components of your architecture, each one in a different GitLab repository. It can become a burden. I know that there are solutions for that. I will refer to the documentation for that. But I've seen it somewhere explained. So it's clearly not something that it's new. You're not the first one to point out this. So I hope this answers your question. Good. So I've been a bit longer than expected, and unfortunately I couldn't show what I wanted, which is exactly my payload running on my Kubernetes cluster. In any case, thank you so much. Thanks for the great questions. Thanks for the attention. And we are going to make available this recording and the slides somewhere. We will notify you in any case. And thank you so much for attending. Thanks for the guys from Amazigh. Thanks to Milo to organize everything and form, and thanks to Marcus for taking care of the questions as well. And see you soon for another webinar. Thank you so much. Bye-bye.
Thank you. Bye-bye. Bye.